Hi, good afternoon, everyone. Hope you're all safe and doing great. My name is Tanim Al-Bashbishi, and it's my pleasure to be presenting this research on behalf of my team at MST. Our research is titled The Role of Transactional Blockchain in Facilitating Procurement in International Construction Projects. So here's the outline of the presentation. We're going to be starting with the introduction, then the goals and objectives, move on to background information, then the methodology, present the results and analysis, and then conclude the presentation with the conclusion. So blockchain has been emerging in recent years as an innovative key technology. Supported by the ongoing growing conversion to online services and online banking, the use of blockchain has been booming in many sectors including banking, finance, and supply chain. However, the construction industry is known for its slow adoption of new technologies and innovations. This case holds true in blockchain as well, even with the literature showing that blockchain has the potential to revolutionize construction procurement and supply chain management. In 2019, for example, in South Africa, an industrial painting contract was successfully implemented and completed using blockchain. The painting project, relied on a blockchain and smart contract system to facilitate management practices such as smart contract administration, supply chain track and trace, access management, safety and compliance management, milestone monitoring, and payment certifications. The utilization of blockchain was considered a success and was noticed to significantly increase transparency between project parties. Still, the inherent unique challenges of the construction industry pose many concerns and skepticism concerning the implementation of blockchain technology in construction projects. This is why the goal of this paper is to provide a holistic understanding of the role of blockchain in facilitating procurement management in construction projects, with a focus on international projects. This goal is reached through achieving three main objectives. 1. Understanding possible applications of blockchain in construction projects. 2. Investigating the blockchain systems that are currently being used in the industry. 3. Studying the advantages and disadvantages of using blockchain in construction projects. Now we are going to discuss briefly some background information about blockchain. First off, what is blockchain? A blockchain is basically a series of validated units of information named blocks. These blocks are connected to one another in a chain-like manner. The first blockchain was developed by an anonymous person or group in 2008 under the alias name Satoshi Nakamoto. A year later, it became the medium for Bitcoin transactions. This is due to its ability to execute and maintain records of financial transactions in a fast, efficient, and trusted way. Blockchain units or blocks does not have a central administrator or centralized data storage. Instead, blockchain creates a distributed ledger that contains records of the data stored in the blockchain. This data can be financial transactions data or any other type of data depending on the use of the blockchain itself. The control of these records is dispersed among the different computers in a network, and this ledger is duplicated to all computers in that network. Accordingly, there is no need for centralized entities such as financial institutions like banks and such to regulate or monitor the process, but rather the blockchain is decentralized, which ensures secure, flexible, and transparent transactions. One of the most common technologies to be used along with blockchain is smart contracts. A smart contract is a software-coded protocol that self-executes according to the terms of agreement between two parties. Smart contracts surfaced for practical use in 2015. How it goes is that instead of a typical contract, conditions of the contract agreement are coded digitally. Then, as the blockchain records events of a given transaction, the smart contract automatically confirms that the contractual obligations related to that transaction have been met, and releases the relative payment. The amount of that payment is also specified in the smart contract. Once the transaction is completed, it's stored in the ledger, forming a block that's stored on the blockchain network. Now moving on to the methodology. The methodology in this research can be divided into three main steps. The first step is a literature review to learn the studied applications or the possible applications of blockchain in procurement management and supply chain in the construction industry. The second step is case studies analysis to highlight the lessons learned based on actual blockchain applications and construction projects. The third and last step is a SWOT analysis to gain a comprehensive understanding of the advantages, disadvantages, challenges, and benefits of using blockchain in the construction industry. Now, moving to the results and analysis. So, according to the survey's literature, research has shown that blockchain has the potential to facilitate numerous applications in the construction industry. These applications may include processes such as data recording and tracking, on-site progress monitoring and scheduling, and conducting financial transactions on an international level. However, it can be seen that actual blockchain systems that are currently being used or implemented in the industry are limited to two main functions: procurement management and payment systems. So, for example, some of the blockchains that are currently used focus on monitoring the progress of the works on site, then processing payments to the contractor according to that progress. Other systems focus on tracking procurement items along the supply chain process. Then, based on the milestones of these items, it conducts financial transactions in order to pay the suppliers. You will find that the types of the blockchain systems found in the case studies that are going to be discussed in the next slide fall roughly within these two types. So, as just mentioned, case studies about the implementation of blockchain systems in actual construction projects were studied and analyzed. An extensive literature review was conducted to collect these 5 case studies. They were actually a bit hard to find, so to the best of our knowledge, this could actually be the only documented academic case studies investigating the use of blockchain technology in construction projects. So the first case study is a blockchain system for integrated project delivery project. The blockchain network includes 7 parties: the client, architect, main contractor, and 4 subcontractors, and 4 main functions: adding participants, calculated reimbursed costs, profit, and cost saving. As for the second case study, it's about a blockchain network for the design, selection, and execution of cladding panels in a residential project. It's a permissioned blockchain network with 6 main parties: the architect, supplier, site engineer, client, building surveyor, and the city planner. In the third case study, a blockchain and smart contract system was used to monitor the progress of supplying and installing facade panels and processing payments to the subcontractors accordingly. BIM modeling was also integrated with the system in order to verify progress achieved on site. The fourth case study also investigated the use of blockchain and smart contracts, but this time to automate the main contractor's payments. The system relied on robotic progress monitoring to automatically translate on-site inspections to payments, in accordance, of course, with the terms of the agreement in the smart contract. Lastly, the fifth case study investigated the use of blockchain in the procurement of a desalination tower from an overseas international supplier. The blockchain was on Ethereum platform, where each of the 2 stakeholders, the client and the supplier, had a private account. Financial transactions were carried out using either cryptocurrency. A SWOT analysis of the cases just discussed was conducted to identify the expected strengths, weaknesses, opportunities, and threats of adopting blockchain in construction projects. So the table right here presents the results of this analysis. So it was found that the strengths mainly include efficient progress reporting, ease of information flow, enforced transparency and professionalism, among others. One interesting weakness was found to be the lack of governmental regulation. This is interesting because lack of government interference is considered one of the attraction points in other sectors such as finance or banking. 2 main opportunities are less reliance on trust between project parties and less need for manual verification by project members. The threats included cryptocurrency volatility and blockchain adoption costs. Of course, we're not going to be able to go through all the SWOT analysis points here due to the time constraint. However, we would like to highlight that a detailed description of each of these points can be found in the conference paper itself. So, to conclude this presentation, the work on this research has presented a systematic literature review and content analysis on the implementation of blockchain technology in the construction industry. The analysis of the case studies showed that almost all of the blockchain systems that were adopted in construction projects were integrated with smart contracts. These blockchain smart contract ecosystems were mainly utilized to optimize two construction management processes: procurement management and payment systems. The application of such systems also included supply chain monitoring and on-site progress monitoring as supporting processes. As for future research, focus can be directed towards exploring new applications of blockchain in the construction industry. For example, it was seen that most of the case studies included in the review have stopped short of utilizing blockchain all the way through to monetary exchange. The use of cryptocurrency is still considered a barrier against adoption of blockchain technology in construction industry according to the results of the SWOT analysis. Further, currently used applications can be also explored for further enhancements. For example, currently used smart contracts are considered not fully smart because they fail to capture and process some construction contractual processes. So more work can be done in that area to fully enhance smart contract abilities. So we have reached the end of the presentation. Thank you so much for listening. I'll be waiting for you in the live Q&A session to answer any questions you may have. Thank you so much.